Welcome back to the Sci-Cast, the show where we discuss all things science. I'm joined by Harry,
Hi.
Zaynah,
Hi.
and the mysterious Dr. X.
Down.
Today, we discuss the significance of the number 12 in the worlds of maths and chemistry, how virtual reality is being used to help treat certain mental health conditions, and MACHOs. I'm Max, and this is the Sci-Cast. As I just said, MACHOs. Harry will tell us more, won't you, Harry?
Yes, I will. So, what exactly are machos? I mean, they might be pronounced just MACHO, but I'm just going to call them machos, just to make it easier. And macho stands for Massive Astrophysical Compact Halo Object. And this is just a big name for any form of astronomical thing that might explain the presence of dark matter in galactic halos. And before we carry on with machos, I'm just going to quickly give a brief explanation on what a galactic halo is. And a galactic halo is a roughly spherical part of a galaxy that exists within and beyond the visible galaxy. You have stellar halos, which is the component containing stars and their systems. The galactic corona, which is not a space virus, but rather the hot ionized gaseous part of the galaxy. And the dark matter halo, which is the hypothetical region that contains gravitationally bound matter and remnants from what caused the formation of the galaxy. So back to machos. This is where it gets a bit odd because I found a bit of a controversy in the specific definition, because most sites say that it's a non-luminous, ultra-compact object that emits little to no radiation, and yet all sources give neutron stars as an example. And this is really odd, as neutron stars do emit light, and they also emit electromagnetic radiation, and they also emit radio waves and X-rays. So I don't really know what's going on here. Does anyone else have a clue?
I have no Scooby-Doo.
No Scooby-Doo.
I mean,
No, me neither.
Zaynah?
No, not at all.
I mean, if anyone does, like, if there's some reason behind it which I haven't managed to find, do comment down below. But how exactly do you detect something that doesn't emit light or radiation? And the answer to this is gravitational microlensing. And this is the process of amplifying the light from a background star when a macho passes in front of it, which increases the light of the star, and you basically get a big black object ringed by light. Hence, when we got the first picture of a black hole, it's, aside from it's absorbing all incoming light, you've just got this big sphere of darkness and then bright red around it. But this is incredibly rare, as the probability of aligning an object that you technically can't see, so you can't track, and then aligning it with a star is ridiculously low. And to get a decent number of accurate results, you need to monitor several million stars over the course of years. And even then, there's a possibility of viewing a planet in orbit that is making just an eclipse. And there's another category that might explain dark matter, which are WIMPs, WIMPs, which are weakly interacting massive particles, but that's a whole other topic entirely.
I absolutely love astrophysics. Like, it's just boom, like crazy stuff.
Yeah. And yeah, it's such a big topic as well. Like, you don't really realize just how much there is until you're, like, looking at it.
Do we know what we think dark matter actually is? Like, what the best theory we've got so far is? If it exists, what would it be?
Well, so the preferred idea behind dark matter is as an explanation for why the universe has an accelerated expansion rate. Because if the universe is existence, how can that increase? Because what can it increase into?
Yeah.
but we don't really know what exactly dark matter is.
And now, from the weird and wonderful world of space to the territory of virtual reality, Zaynah explains how it's being used to help treat certain mental health conditions.
Thanks, Max. So for us, this week was actually Children's Mental Health Week. And we talk about this topic more and more today, as we should. 1 in 4 of us will experience some kind of mental health issue at some point in our life. So my question for all of you is, what's the first thing that comes to mind when I say these 3 words? Mental health, depression, and anxiety.
Am I allowed to say NF?
Yes?
I'm absolutely obsessed with him, but his music is really good and emotional, and he explores mental health a lot. So I do think of him a lot whenever I hear those words.
Yeah, I think I agree with that. It's kind of like an emotional outlet as well to
Yeah.
express. What about you two?
Yeah, I mean, obviously it's a difficult thing to deal with. It can be quite sad for some people and upsetting, but it's an important thing that needs to be addressed, I think, and I think it's important to address it in a commensurate and correct manner.
Yep. Harry?
To be honest, my brain also goes to music because I think back to like any experiences I've had with it, and whenever I'm struggling with like anxiety, um, my outlet is always to just listen to music because I'm a big fan of anything that's like quite guitar orientated, and I don't know, it's just sometimes I need to like listen to some good fast paced, get me motivated, or just down music to let the feelings flow.
Wow, all of your answers were a lot more noble than I expected. And so today, what I'm talking about is, I think one day your response when you hear those words might actually be virtual reality or VR. So this is slowly becoming the frontier for treatment for mental health. And face-to-face therapy has been seen to be really useful for many people who do suffer from different mental health problems. And one of the newest approaches at UCL University is actually involving VR therapy alongside the face-to-face therapy for depression. So basically, the system uses a virtual room, right, where there's 2 avatars, a child and an adult. And this avatar can actually be made to look like you if you choose to. Now, before you enter the room, you're trained in how to use a compassionate script to lift the mood of someone who's distressed. And there are 3 aspects to this script: validating experience, redirecting attention, and activating a positive memory. Okay, so you got all those 3 factors. Now, you're going to enter the virtual room and be confronted with the distressed child. And your task is basically to comfort them with this script until they become less distressed. Now, here's the weird, clever bit. The next time you enter the room, you are the child, and you kind of get to see the adult avatar version of yourself performing this script, and you basically sit there as a child and literally have the experience of compassion. So I think this is slightly mad, but actually it does work. And the initial results have shown significant reduction in measures of self-criticism and depression, as well as improvements in self-compassion. And I guess the hope is that a larger trial will begin for people undergoing treatment for depression. So this is only one of the newer technologies currently being developed, but the use of virtual reality in this context has been around since the mid-90s, and probably one of the more established uses is for anxiety. So Oxford have developed a VR headset for simple phobias where there's predominantly one fear, and then this can be used to expose the person to that fear gradually and safely. So I guess the general consensus is that VR therapy could be even more powerful than traditional therapy. And the ultimate aim is using the technology not just to replicate successful therapies, but to push them even further. So, for example, in cases of PTSD for war veterans, you can kind of get like war situations which are simulated using 14 customizable virtual worlds. And through most of these programs, a human therapist, controls what happens, tailoring the content to the memories of the person reliving the trauma. And to finish off with, even if you don't suffer from mental illnesses, it's becoming more useful in the context as well, just for general well-being, relieving stress and relaxation. These programs that I've discussed don't require a qualified clinician and can be delivered by a trained member of staff, meaning that therapists can be reserved for more urgent cases.
Wow. That is so cool. And depression is it's a really, really, I think it's quite it's a big topic at the minute and in general. So I think it's really good that they're trying these new technologies to try and help and treat it.
Definitely.
Yeah, it sounds pretty promising. Yeah, especially if it's managed correctly, which it seems like the steps being taken towards that. It could really be a force of positive impact.
Yeah, I definitely agree, because the aim isn't to replace therapists, it's just to improve the experience and get better results, I guess.
Yeah.
Like roughly how much is being invested in this? Like how many people are working towards making this like a plausible method of treatment in the future?
Well, I think currently, I'm not sure the exact statistic, but like millions of pounds is being invested into just general mental health treatment. But if you get enough people to use this kind of virtual reality, then like the overall cost savings will be like huge. So I guess it's just a matter of how much they can implement it into like clinics and stuff.
I suppose there's also a case of if you're struggling, like if with time to go to a therapist, like if you're being like work really hard throughout the day and you don't have an hour or two to be able to like drive somewhere to see a therapist, you've always got like VR at home that can help you out.
Exactly.
We now shift from cutting-edge treatment to something completely different: the significance of the number 12. So, Zaynah, what base is our number system? Do you know?
I'm going to guess 12.
12? Why? No,
What?
it's not 12.
No, I don't know what base.
Oh, okay. All right, Harry. What base is our number system? Do you know?
Well, I'm probably massively overthinking this, but my brain's just gone binary, ternary, hexadecimal, and we use hexadecimal. Yeah, we use hexadecimal, don't we?
No.
Oh,
Dr. X. What is
That
our
was
base?
that was a computing reference, wasn't it?
Yeah.
Well, okay, it's base 10,
Yeah. It's
which is
yes, base 10. And that's because there are 10 different symbols that we use, so 0 through to 9. And other than computers, which use binary, as Harry said, which is ones and zeros or base 2, base 10 is by far the most commonly used number system in the modern world by humans. But welcome the Dozenal Society of America, or the DSA for short, if you like to be cool. Now, I read this in a book written by a guy called Alex Bellos. I hope I pronounced that correctly. Called Alex's Adventures in Numberland. Definitely worth a read. Really good book. And in the book, it talks about the DSA, which is this society that is calling to change the number system that we use to base 12. Now, of course, that would mean adding 2 other symbols. So you'd have the 0 through to 9, and you'd have 2 others, which you can see on the image in the top left of the corner is 2 other symbols called DEC and L. Looks a bit like an X and an E almost. But I'm sure you're asking, why are they calling for base 12 of all the other numbers? So, Zaynah, I'll come back to you. What were, for you, the easiest times tables to learn in primary school? You've got to think back here.
2 times tables.
The 2s, yeah. What else?
5,
Yeah,
10.
yeah. And you probably say the 1 times table as well, if you count that as a times table. Now, what do you notice, Zaynah, about those numbers?
Well, 2 is just doubling, and 10 you just add a 0.
What do you mean by that?
When you're multiplying by 10, you just add a 0 at the end.
Not what I was thinking.
Yeah, I'm not sure.
Okay, well, they're all factors of 10. 1,
I was
2,
gonna
5,
say
10.
Oh yeah, that probably
Yeah,
makes more sense.
So, Dr. X, what are the factors of 12?
The factors of 12. Okay,
Yeah.
you put me on the spot for this one. 1,
Yeah.
2, 3. Oh my word. 4,
Yeah.
6, and 12.
Yes. Now, I'm sure you probably noticed there are more factors for 12 than there are for 10. So this suggests that there are more easier times tables that you can learn in dozenal than in base 10, which is what we use, of course. This might mean that it might make mental maths a bit easier if you use base 12 or dozenal, because it allows for cleaner fractions and ratios. And in fact, you can see on the image that all the list of times tables for those are quite easy to learn in base 12 because there's a repeating pattern that accompanies it. And this isn't really new. In fact, the word grocer, which is from the groceries where you go and buy fruit and veg, in fact, the word grocer comes from the word gross, which means a dozen, or 144, which of course is 12 times 12, 12 squared. So it shows perhaps this historic preference for using the base 12 number system. And it even suggests why some people might like or prefer to use imperial units, dare I say it. Because 1 foot, of course, is 12 inches, which can be divided quite easily by 2, 3, 4, and 6. So if you're a carpenter who needs to do kind of quick mental sums, it might be more easy to do that in a sense. You have more options in a sense. Now, is the world going to change to base 12 all of a sudden? Absolutely not. Obviously, it'd be a huge faff, wouldn't it? Imagine trying to relearn all the maths you've been taught in school up until now. But some people quite prefer to convert between bases when they do work, just to help with the numbers a little bit. So yeah, quirky, and I don't think it will happen, but still pretty cool.
Very quirky. I absolutely love base 12.
Yeah.
Like, I absolutely love it. I wish we did use it instead of base 10. Obviously, just as you said, switching was just not really plausible. But if we grew up using base 12, I imagine that would have been exceptional, in my opinion.
Yeah, I think you want to start from early rather than just switching to it. That'd be a nightmare.
Yeah,
So if we did start with this, do you think it would be a lot easier for children to pick up?
It possibly would be, yes. I mean, obviously maths is only easy to a certain extent, and then it will still become complex. But I think it might actually, possibly, yes, in a sense. But it's never going to happen, of course, because that society would never change. Not only would that cost billions or possibly trillions of dollars and pounds, it would be a nightmare. Let's put it that way. And finally, sticking with the theme of the number 12, it's over to Dr. X to discuss the amazing nature of the element carbon. And you probably ought to explain how it relates to the number 12, don't you, Dr. X?
Right, yeah, of course. So, carbon has a relative atomic mass number of 12, which means if you had like a mole of carbon, which is not something that burrows underground. I mean, it is, but it also means if you have a certain number of carbon atoms, the total mass of all of those atoms will be 12 grams. And it also means that there are 6 protons inside a carbon atom, which are positively charged. There are also 6 neutrons, which don't have any charge, and they contribute to the mass number being 12. carbon's got a mass of 12, as we've said before. It's got 6 protons, 6 neutrons. It's also got 6 electrons. It's also used for things such as carbon dating, which is why you want to find out how long something's been around for. And it mostly has a mass of 12. There is like 0.1% of carbon around the world, something like that, that has a mass of about 14. But most carbon has a mass of 12, and it's one of the most stable elements in that regard. The final thing I want to say about it before launching into this piece is it's got it's got it's got 4 electrons in something called its valence shell. What that basically means is when it reacts, it can form up to 4 bonds. So moving from there, I think a great place to start is with the hardest material on Earth, which is Harry.
I know tungsten has the highest boiling point, but isn't it titanium that has the strong? It's the strongest metal, but diamond is also stronger.
Okay, that was a brilliant response. So diamond is the hardest material. There's a difference between hard and strong, which is effectively hard is like it won't scratch. Strong is like it's hard to sort of destroy and crush. But diamond is that also precious crystal is sort of meant to be the hardest material on Earth. It won't scratch, and that is completely made out of carbon atoms. So diamond is pure carbon, and each carbon atom bonds with 4 other carbon atoms to form this tetrahedral structure, and that's really difficult to overcome and separate the carbons in that structure, especially because the carbons are so small themselves. So that's what leads to diamond being so hard. But carbon isn't limited to just forming the purest of diamonds. You might have heard of vibranium. Well,
Isn't that
we've
from?
got
Isn't that from? What's that Marvel film?
yeah, Black Panther.
Yeah, that's a film. I swear.
Yeah,
Yeah, it's
it is.
fiction.
It is fiction, and vibranium's completely fake. But it's meant to be this like super material, right? That can be used for all sorts of things, exceptionally. And we've actually got something kind of similar to that. It's not quite as extraordinary, but we have graphene.
Oh.
And yeah, graphene. Graphene is it's often confused with graphite. Graphene is one layer, where graphite is multiple layers. And the difference, and what graphene actually is itself, is it's a network of carbons which are each bonded to 3 other carbons, which means they only form 3 out of their 4 possible bonds, and they form this structure. Do you guys know what the structure is?
Hexagonal?
Yes, it's a hexagonal structure. It looks just like a honeycomb. And that means that a graphene is also very strong. It's also got multiple other properties, such as its ability to conduct electricity, because instead of forming all 4 bonds, it's got that one electron left, which can move around and carry charge. And graphene is I compared it to vibranium because it can be used in so many different aspects of life. It's pretty cutting edge. Its progress hasn't been so fast because sometimes it's not really that financially beneficial, but it can be used in all sorts of applications from technology to medicine. And it's remarkable because its other properties include flexibility and transparency. It's also the first. It's called a 2D molecule, material, 2D material, and that's because one sheet of graphene is pretty much flat, so they call it a 2D material. So what's the major difference between graphene and graphite?
Graphene is a single layer.
Yes, and graphite is multiple layers. So whereas graphene is pretty hard, graphite actually ends up being pretty soft. We're still dealing with the same carbons, pretty much the same structure, but now because you've got layers of graphene on top of each other to form graphite, you've got a material that's so soft it will literally just slide. The layers will slide off of each other, and that is what's used in pencils instead of the poisonous lead. It's called lead, but it's actually graphite. which means sometimes graphene finds itself asking graphite, to be or not to be? That is the question. I thought I had to do that. There has to be a bad joke in there somewhere. But carbon is so much more versatile still. Buck up for Buckminster Fullerene, which is essentially balls of 60 carbon atoms. Max, you mentioned this earlier, buckyballs.
Yes.
And that is the name that is given to these balls of carbon, which were discovered by a guy called Buckminster Fuller, which I think is an exceptional name. And
yes.
yeah,
I mean, imagine the register.
yeah,
Buckminster. You're either going to get bullied or you're going to be loved. Like,
so true. So true. And yeah, Buckminster Fullerene has a much lower boiling point than diamond, graphene, and graphite. Again, we're dealing with the same substance. We're still dealing with carbon, but this time it arranges itself into balls, kind of like footballs, with sort of small hexagonal structures that are linked together, and that is so different because it's like a nanometer wide, and it's got a boiling point that is so much lower than that of diamine, graphene, and graphite. And it's also used in a variety of applications, many medical ones as well. It can be used as a lubricant as well because it's so much softer as well. And then a few more things I want to say. Nanotubes are effectively a cross between graphene and buckyballs. They are cooled into this sort of tube structure. So imagine you had a honeycomb and you've rolled it up into a tube. That's effectively the structure of a nanotube, and they are extraordinarily useful as electrical conductors, but they're also really strong, yet they're incredibly small. Right, so you know how I love big words?
yes.
Next has to be linear acetylene. Words so big that I can't even say them properly. Linear acetylenic carbon, which is often called carbine for short. This is probably the newest addition to the list, and what it does, it's quite unstable at the moment, so they do have to use nanotubes to try and create long chains of it. But it is stronger than graphene, which is itself like 20 times stronger than steel, and it consists of a chain of alternating bonds between carbon atoms. So you have a triple bond here, so you've got 3 bonds shared between 2 carbon atoms, and then the 4th bond will be between 2 different carbon atoms. So you've got a triple bond, then a single bond, then a triple bond, and a single bond. And that seems to have loads of potential for future uses if we can increase its stability. And then there's also, finally, the theoretical structure that's meant to mix the triple bonding you find in carbine with the structure of graphene to produce something that they will call graphine. Last but not least, carbon makes life. All life we know of is carbon-based, and that's because of its immense versatility and the different structures it can form that we've already been talking about. So everything I've spoken about today has been centered around just pure carbon itself, but when carbon reacts with other elements like hydrogen and oxygen, the realms of possibilities are life as we know it. And that's why an entire field of chemistry is built around one element. The only thing left for me to ask is for carbon to go on a date with me, because it has so much to offer. Carbon dating.
I was going to say, you should clarify the difference between that, but... Oh, brilliant.
That was good.
That was good.
No, that was a good joke.
Oh, thank you very much.
That's all from us today. Thanks once again to Harry, Zaynah, and the mysterious Dr. X. Be sure to like, subscribe, share, and check out our other videos. That's all from us, and goodbye.
Bye.